Hello everyone, this is Kruti Shah and I'm going to walk you through my research work on movie recommendation system using fuzzy control system. The agenda is as follows. We'll be going through the introduction, then content-based filtering, fuzzy Mamdani control system, methodology, then discuss results, conclusion and future study. Movie recommendation systems play a pivotal role in helping users discover content tailored to their preferences. Traditional recommendation systems often rely on statistical approaches, but there's a fascinating alternative, fuzzy Mamdani control systems. This paper explores the integration of fuzzy logic into movie recommendations, utilizing the renowned Mamdani model and comparing it with the traditional recommendation system. The approach studied here is content-based filtering. They are solely based on item features to recommend other items similar to what the user likes based on their previous actions or explicit feedback. What is content-based filtering? Content-based filtering uses the attributes or features of an item, this is the content part, to recommend other items similar to user preferences. This approach is based on similarity of item and user features, given information about a user and items they have interacted with. For example, a user's age, the category of a restaurant cuisine, the average review for a movie. Model the likelihood of a new interaction. For example, if a content-based filtering recommender sees you like the movie You Have Got Mail and Sleepless in Seattle, it might recommend another movie to you with the same genres or cast, such as Joe versus the Volcano. The other type of filtering is collaborative filtering. Collaborative filtering algorithms recommend items based on preference information from many users, and this is the collaborative part. This approach uses similarity of user preference behavior given interactions between users and items. Recommender algorithms learn to predict future interactions. Collaborative filtering is not in scope of the paper here. The fuzzy Mamdani control system is a type of fuzzy logic controller developed by Lofty Age. It is designed to handle complex systems by incorporating the concept of fuzziness to model uncertainty and imprecision in decision-making processes. The Mamdani model specifically is a fuzzy inference system that uses linguistic variables and rules to make decisions. Fuzzification is the first step that involves converting crisp input values, that is quantitative data, into fuzzy sets. And the fuzzy sets allow for the representation of vague or imprecise information. Linguistic variables are used to describe these fuzzy sets. For example, if the input is temperature, fuzzy sets like cold, warm, and hot might be defined. Now, the rule base. The system relies on a set of rules that define the relationship between the fuzzy input variables and the fuzzy output variables. These rules are typically in the form of if-then statements and capture the expert knowledge of heuristic understanding of the system. And each rules combine one or more conditions and specifies an action to be taken. Inference engine. Fuzzy rules are used to the fuzzy input values during the inference phase to produce fuzzy output values. Based on the input values, this step entails calculating the extent to which each rule is satisfied. A collection of hazy output values connected to every rule is the end outcome. Theoretically, the number of rules in the inference system is calculated as R is equal to pi from 1 to n fsi, where r is the number of rules, n is the number of input variables, and fsi denotes the number of fuzzy sets assigned to the ith input variable. So based on this equation, the number of rules directly depends on the number of input variables and fuzzy sets in the system. Now the last step is the defuzzification step, and that involves creating a crisp output from a fuzzy output values, and we refer to this procedure as defuzzification. Defuzzification can be accomplished using a variety of techniques, including centroid, mean of maximum, and others. We'll look at the methodology adopted to this project. We'll discuss the program requirements, the data set, data pre-processing, fuzzy control system, and the traditional statistical methods. The data set used here is for the movie recommender system is the movie lens dataset. This dataset is available on Kaggle and can be downloaded from the same. There are 4 CSV files available with this dataset. Only 2 dataset files are used in this project, and the 2 dataset files are movies.csv. That is, movie information is contained in this movies.csv, and each line of the file contains information about the movie, and the fields are movie ID, title, and genres. The second CSV file that is used is the ratings.csv, and all the ratings of movies are contained in this file's ratings, and each line of the file after the header row represents one rating of the movie by one user, and it has the following format like user ID, that's a particular user, movie ID, the rating, and the timestamp. The program requires Python 3.7.4, and the Scikit fuzzy library needs to be installed, which is a collection of fuzzy logic algorithms intended for use in the SciPy stack written in the Python computing language. So let's look at the data preprocessing that we have considered for this project. The title has the movie's name and the year that it is released. The year of the release is scraped off from the title and stored as another column at the end of the data set. And the genres are pipeline separated, and the pipeline is removed and they are stored as a list with commas. Later, the genres are each one hot and coded, and a column for each genre is created. If the genre is present, the genre list, then the value is 1, otherwise it is 0. So if we see the example over here, we have for the first movie, we have adventure, animation, children, comedy, fantasy. So only these genres will, when we hot and hot and cold, we'll have the uh, column added for each type of genre. And now for this movie, we'll have adventure as one, animation as one, children as one, comedy as one, and fantasy as one, and all others genres like sci-fi or drama or other things will be 0 as they are not present. The timestamp from the ratings.csv is dropped because that's not required. And the input data used in this experiment is the all the 5 movies have action and adventure as genres, so we have considered that, and the rating. So that is our input data. For this system, I decided to use 2 types of input variables, aka antecedents. The movie's genres and the ratings from ratings.csv for that movie. The user's movie input above shows that all the 5 movies have action and adventure as their genre. In the interest of time, to narrow down the scope and of the project and to minimize the number of rules to be coded, I am considering only 2 genres, that is action and adventure. And the output variable, aka consequent, is the recommendation percentage. One can specify different membership functions. For this, I have used two types of membership functions, the triangular and the Gaussian. And in the provided code, I used Gauss SMF for the rating and trimf for binary genre variables and trimf for the recommendation output. You can choose the appropriate membership function based on the characteristics you want to capture for each variable in your fuzzy system. Inference engine, here we need to specify the rules by which fuzzy inputs are connected to the fuzzy output. And the rules look like this. If the rating is low and action genre and adventure genre are not present, then the recommendation is low. If the rating is low and action genre is not present and adventure genre is present, then the recommendation is low. Or if the rating is low and the action genre is present and the adventure genre is not present, then the recommendation is low. So in the similar way, there are four rules for each of the medium, high, low ratings, and the complete list we can see it over here. I've given a snapshot of the code, and the rule base of the current system includes 12 rules in total, and important to ensure that the input variables value activate at least one of the rules in the rule base. Otherwise, you will get an empty set. And the rules for the system were derived somewhat arbitrary. In reality, there are rigorous approaches to do that. And there is also a way of deriving these rules from the data and fuzzy adaptive system or fuzzy neural networks can be used for that. And the rules include two operators. Here I've used only one operator, that is AND operator, but there are two operators we can use, and OR. And the AND operator implies minimum operation and on the respective set, and OR operator implies the maximum operation on the set. And these rules, as I said, use only AND operator. This is the picture of the rule 1, how visually that looks like. So the last step in fuzzy control system is the defuzzification. And defuzzification is a process of representing a fuzzy set with a crisp number. Internal representation of data in a fuzzy system are usually fuzzy sets, but the output frequently needs to be crisp number that can be used to perform a function such as commanding a val to a desired position in the control applications or indicating a recommendation percentage as discussed in this project. The most commonly used defuzzification method is the center of area method, also commonly referred to as the centroid method. And this method determines the center of the area of the fuzzy set and returns the corresponding crisp value. The center of sums method and the mean of maximum method are also two alternative methods used for defuzzification. Now that we have our rules defined, we can simply create a control system via to simulate this control system. We will create a control system simulation. Think of this object representing our controller applied to a specific set of circumstances. For recommendation, this might be recommending a movie to Karen. We would create another control system simulation when we are trying to apply our recommendation control for Travis for TV shows, because the inputs would be different. Now let's discuss the traditional statistical method used in this project. So the first step is to create a user profile, and this is done by multiplying the one-hot encoding values of the genres with the rating, and this will be done for each of the shortlisted movies. Once this multiplication is done, we will add up the values of each genre and we get a single value which will be the user preference weightage for the particular genre as shown here. And the above table here the table is called the user profile, as this is for a particular user. The final step in the recommender is that we take the one hot encoded genre for each movie and multiply the genre with the above score for each genre. We do that for all the movies and then we sum up horizontally. That is the sum of all the genres of that movie, and then we normalize it by dividing the uh, above score. And so this table over here is the user table, user profile for a particular user, and this is the equation that I just explained. The process how we take the hot encoded genre table for each movie and then multiply by the user profile, and then we sum up all the genres horizontally and then we normalize it. So this is that uh, equation, and then once we apply that equation then we get the percentage for the recommendation, and then we sort the movie on the score and choose the top 10 movies for recommendation. Now let's discuss the results that we got from both the the fuzzy control system and the traditional statistical approach. So our analysis reveals a notable discrepancy in the top 10 recommendations generated by the fuzzy control system and the statistical approach. This discrepancy is likely attributed to difference in the number of features considered by each approach. Specifically, the traditional approach incorporates all 20 genres in the calculations, while the fuzzy control system focuses on only two genres. Considering the inclusion of 20 genres and one rating, the traditional approach involves 21 features, resulting in a calculation complexity of 120 rules. To mitigate the challenge posed by the increasing number of features in the fuzzy control system, several methodology can be explored, and these include rule-based reduction, rule aggregation, rule interpolation, fuzzy clustering, learning methods, and hierarchical fuzzy systems. These methods offer potential avenues for future research aimed at reducing the number of rules and enhancing the efficiency of fuzzy control systems. So let's discuss the conclusion for the project. The fuzzy Mamdani control system offers a straightforward implementation, particularly due to the simplicity of rules expressed in plain English. In the light of these findings, our study not only underscores the potential of the proposed alternative fuzzy Mamdani control system, but also acknowledges the challenge posed by the escalating number of rules, especially in correlation with an increasing number of features. So we not only conclude, but we also suggest a future study. And for the future study, we can consider more features of the movie, such as consider all genres, actors, directors, and description of the movie for enhancing recommendation accuracy in movie recommendations. Since the greater number of features will pose the exponential growth of the number of rules, implement and adopt rule reduction techniques and implement collaborative filtering to incorporate other user preferences who watch similar movies. So here are the references and the citations that are used during our study of this project. And thank you everyone for your time and attention. I hope this would have helped you to learn about the fuzzy control systems. Thank you.